I screwed up my introduction, didn't I? So, welcome to my talk. Thanks for being here. I'm Henning. I'm with OpenBSD since 2002. And today, for the first time ever, at least at such a conference, I'm not going to talk about my work in OpenBSD. I'm not using the microphone. Sorry. So today, for once, is it on? No? Is it on? Yes. So for once, today, I'm not going to talk about my work in OpenBSD. This working fine? Thanks. But I'm going to talk about how we use OpenBSD at my primary company. And that happens to be a smaller ISP called Web Services GmbH, the legal form, in short BSWS. Please don't ask me about the name, I was young and stupid. The roots go back to 1996. The business model back then was slightly different, so we are basically an ISP since 1998. That's pretty early. The computing world looked different then, very different. We offer all kinds of hosting, basically anything you want to do with a fast internet connection, static IP and all that kind of stuff, we'll almost certainly do. We don't offer internet access, as in DSL or cable or something like that, with the exception of our office building, so this is the part of ISP stuff that does not concern me. And we largely run on OpenBSD. It's actually almost exclusively. It's like 5 boxes running other operating systems total that we control, not customer control boxes. Hosting ISP networks are one of the most hostile network environments you can find in the world. There are several requirements that make them pretty special. You really need to get as close to 100% availability as it gets. There is no after hours. There is no every employee went home and the network can be scrupulous. It just doesn't happen. So things pretty much always have to work. At the same time, pretty much everything you do is internet facing, offering public services, so the attack surface is quite big. And to make matters worse, you have to have, or almost certainly have, machines on your network that are not under your control. You supply power and network and that's it, and cooling and stuff. And denial of service attacks, and especially lately this has been a large problem, distributed denial of service attacks are very, very common. And yeah, sorry, I cannot handle 100 gigabits. Due to this requirement, network segmentation is a big deal. You want to isolate your own boxes from those that are under customers' control. Chances are they don't care about their host security as much as we do for ours. We even want to split our own machines into groups that are pretty nicely isolated. And you also want to isolate the customer-controlled machines from each other, as in the customers from each other. Single customer running 5, they don't need to be isolated usually, but from other customers. Which in turn means you're going to run many VLANs, like many, a lot. And that comes with quite some network complexity, which especially has an influence on the switch config. So just putting a switch into the rack and plugging cables in this environment really doesn't cut it. Opposed to most other ISPs, we actually deploy firewalls. This is unfortunately pretty uncommon. We have them between the servers and the internet, but we also have them between all those VLANs, because as I said, we want to isolate the customers from each other. So, why OpenBSD? Initially, could claim this is kind of a coincidence. We were running a couple of Linux web servers and had a denial of service attack. I believe it was 98, maybe it was 99. That box really behaved poorly and stopped working, basically. At the same time, some colleagues switched their name servers to, I believe it was FreeBSD, and were pretty happy with it. which made me look at the BSDs. I tried FreeBSD, I tried OpenBSD, and then I stopped trying because what I saw on OpenBSD I really liked. I had parts of the attack recorded and replayed it against the host, and it dealt very nicely with it. I unfortunately don't really remember what details these are, because back then this didn't seem to be such a big deal. So OpenBSD worked nicely. I just liked what I saw, so I stayed with it, and over time pretty much switched everything we have to OpenBSD. There's more to it though. There of course is a reason we stick with OpenBSD. The big point for me is no surprises. Whenever a box acts surprisingly, that's not good and requires manual intervention and work and maybe service downtime, and that's all you don't want. For our use cases, its behavior is always and has always been predictable. It's also been rock solid. In the late 90s and early 2000s, that statement would not have been true. Like in the early days, we did have stability problems. But well, that's long gone. And looking back, I'm by now pretty convinced that a couple of those, not all of them, but a couple of the stability issues were actually caused by crappy hardware. The environment back then was very different. I mean, rack mount servers basically didn't exist or just started to show up. So very different than today. Actually, back then, most internet servers were Sun Ultra One machines, desktop workstations. OpenBSD for us is very efficient in the administration. The same defaults approach saves us a lot of time. We don't need to work around the requirement to get a box ready, push buttons, change configs. We don't need to go for custom kernels or builds. We use the regular OpenBSD builds that Theo usually does. And we quite rely on the stable packages and bin patches that Mtier thankfully provides, that also lower our workload to building those ourselves. The package tools are a big deal for us. So the policy really is we do not tolerate any binary that is not part of OpenBSD base or a package, period, no exceptions. We usually don't need to build ports. All the standard ports, we just use the OpenBSD supplied packages. No need to fiddle with anything ourselves. Of course, we do have some custom ports and the resulting packages for unpublished in-house code. Yes, we have that, and I'm not going to publish everything I ever wrote. Some things I'd be ashamed, to be honest. Very few, though. And we also have very few, less than 10 OpenBSD ports that we modify to our needs that are so special and bizarre that there's just no point and purpose to have them in the generic OpenBSD ports. And again, the big point there is no surprises. It's always predictable. The package tools themselves are pretty awesome these days, and they just work and never screw up. Big deal for us, really easy upgrades. Upgrading OpenBSD base, in our environment at least, is trivial. We use an unsupported method, which I'm not recommending. Let's get clear on that. I don't recommend doing that. We usually overwrite the binaries on the running system, reboot, and be done. This is playing fast, and the risk to lose is high. This works because I'm very close to OpenBSD and know upfront when things are going, but it's not going to work that way. So I really recommend using the BSDRD method. Don't copy our method. Sysmerge takes care of the OpenBSD config files, and these days it barely ever shows me the diffs, as it almost always works completely automatically on its own. Package add, again, our package tools to upgrade our packages. There seldom is manual intervention needed. It usually just works. When there is manual intervention, this is usually due to the packaged software having been changed, like a major version upgrade of a piece of software. And well, nothing packaged tools can do about that. And that is known upfront. We have that process largely automated. We don't have the roles to do scripted reboots yet. So there actually is somebody watching that process, but there's very, very little manual intervention. And again, that saves a lot of time. Performance. This is actually a bit funny because I've been working on performance in the OpenBSD network stack for so many years, and this has been one of my core areas of work. In our use of OpenBSD, performance has really never really been an issue. The tendency is good or better, always sufficient. I remember exactly one case where we had a performance problem that was to be blamed on OpenBSD many years ago, more than a decade ago. That was a very busy MySQL server. And by now, I believe part of the problem was that specific RAID controller driver. Doesn't matter anymore anyway, because it's more than a decade ago. But back then, I ran one FreeBSD box which behaved better in that regard. I didn't like it. So basically, whatever it is it web service, firewalls, routers, load balancers, the mail service, the database service, the application service, DNS service. We don't really need to worry about performance, especially not these days with the super fast machines. It's very clean for us. Of course, every now and then there are some performance problems, but seriously, no operating system can fix stupid application code. There was a case last year which made this very, very obvious. It was a customer calling us complaining that his VM is too slow. And I'm checking and they are burning CPU like mad and asking them what they actually do. And it's a little voting thing where the visitors on the website click yes, no, or option 4, whatever it was, and displaying the results all the time. I helped them by assigning more CPUs, and the next day they call, yeah, we found the problem. Our script was basically doing a select star on the vote database, and then use PHP to count. When you're dealing with 100,000 votes and more, that doesn't cut it. And whatever the OS does, can't fix this. Big point, obviously, is security. A compromised system sooner or later means the services will be down. And, well, that makes customers unhappy. A compromised system also can be a problem with data theft. Think credit card numbers. Customers unhappy. In short, whenever the system is compromised, customers are unhappy, and that in turn is more work for us, and, well, we're lazy. Since most services are public and internet reachable, the attack surface really is big. So security is critical in this use case. And we unfortunately have to run a lot of, from my point of view, questionable third-party code. Do you trust PHP? Do you trust Java? If so, please stop doing IT. Due to that, the mitigation techniques that OpenBSD applies are really important to us. The PHP people screwing up again is bad enough. OpenBSD preventing that from being exploitable is very valuable to us. In some cases, the changes done in the OpenBSD port tree saved us. In case of security, OpenBSD really has never ever let us down. We haven't had a single case of a compromised OpenBSD host in more than 15 years when running hundreds of them, which I find very impressive. We did have a couple of cases where customer installed and controlled web applications have been abused. The typical case, of course, being some stupid contact us by sending email form that allowed the attacker to specify the destination email address. The typical form mail prep. Again, not much you can do at the OS level about that. But still, a couple of these issues have been prevented by OpenBSD things or changes done in ports. This is very valuable to us. The port tree people are very security conscious, of course, and sometimes prevented bugs in that third-party software due to patches that our port tree applied. So in general, OpenBSD is just doing what it's supposed to do. It doesn't annoy us, it doesn't cause us extra work, and something I value a lot, it lets us sleep at night. Because I don't have to worry about the box being taken over by somebody. We're still very security conscious, of course, but I don't have to worry about that much. I also don't have to spend, either me nor our employees, have to spend the nights convoluted upgrade processes. Friends working for in other environments, in sysadmin style jobs, often spend entire nights upgrading 1 or 2 boxes. We don't need to do that because it's so efficient and fast, and you either can even do upgrades at daytime because everything is redundant, or it's at least very fast. We also don't need to spend the nights fixing and dealing with crash machines because that's these days barely ever happens. So when dealing with a large number of OpenBSD hosts, managing them, of course, is quite a challenge. In an ISP environment, a very high automation level really is a must, and last but not least because the margins in this business aren't all that high. We use our very own system for that, developed over the last 15 years, that largely is written in Perl. It deals with much, much more than just OS management. I'm getting into that more detail a little bit later. It obviously has to deal with machines and virtual machines. Obviously has to deal with a lot of services. But there are also things like billing and bookkeeping, interfacing to banks, has to deal with wages, the little tax pre-announcement requirements, and in the end has to export all this data to a tax advisor. And you need to supply web interfaces to customers for self-service, because whenever they call support, that costs man-hours, and man-hours are expensive. A surprisingly complex part of these web interfaces is a sign-up process for new customers, because there's so much fraud these days that you really gotta be careful. So for managing the OpenBSD hosts, our system has a periodic task on each and every machine, which is polling the central systems. The advantage of that versus the central systems going to the managed hosts is that it also works in machines that are kind of detached. My laptop is under control of that system, and that works from here. If it was the other way around, no way. So basically, it contacts our central hosts, retrieves configuration information, and applies that. That includes things like SSH public keys that don't believe in passwords. In the other direction, it sends inventory information, like hard disks, temperatures, are the fans working, what packages are installed, which version of OpenBSD is on it actually, stuff like that. It also applies the bin patches and stable package upgrades fully automatically. So please empty or don't screw that up. If I was starting such a system today, I would make use of one of the many orchestration frameworks. But we started this 15 years ago, and back then there just was nothing. Yeah, well, CF engine, but really that never was an option. Changing that now would be a lot of work, I still suspect that is going to happen one day, integrating one of these frameworks, because they are more powerful and more generic than what we have. On the other hand, what we have is already there, is tailor-made to our needs and works, so there is not much of a point to change that now. But if you're starting from scratch, use one of the frameworks. Auto-install is pretty important to us. The OpenBSD installer gained an auto-install mode a couple of years ago. Basically, it fetches a response file over HTTP. The bit that prevented us from using this for a long time is that this implied the auto-partitioning inside disk label, which was targeted at, well, it's one big compromise, of course, because it was one size fits all kind of thing, and it didn't fit our needs at all. I fixed this about a year ago, and the auto partitioning template is now also fetched over HTTP, and we are using that install.site mechanism in the OpenBSD installer, where basically runs your custom bits at the end of the installer. There I plain copied the ask functions from our install script, which automatically gives me the HTTP response file technique for free. We do run a dedicated, isolated, the subnet isn't even routed, install VLAN that has all the netboot infrastructure, so everything is netbooted. The way this works for us, this is our requirement of the general. We need to know the MAC address first and have to have an entry in our machine management systems for that host before installing it. These days it's really convenient. I haven't seen a server in a long time that did not have its MAC address as a barcode. So barcode scanner, drop them down. No typos in MAC addresses. Our system then reconfigures the DHCP service in the install network to always supply the same IP address, so we can identify hosts by IP address. And if the target VLAN is DHCP, that DHCP2. And most target VLANs we do static configuration. But no matter what, even when using DHCP, we always use static IP assignments. So they will always get the same IP address. In our case, the response files aren't files. We're using, it's right here. Well, now I'm making him happy finally. Yes, right, I'm using your HTTP. And the little fast CGI server behind, and the response files are generated on the fly based on the configuration information from the backends. I keep saying it takes us about 50 minutes to get a new server live. And that's true. And that actually includes unpacking and racking it. So this process is very, very fast and efficient for us. A kind of special case are virtual machines. There the process is in the neighborhood of 90 seconds. And it's 100% automated. Basically, how it works, our system has to figure out the MAC address, in this case, like generate one, retrieve the configuration bits, like the number of CPUs and the amount of RAM and all that kind of stuff, setting up the VM infrastructure. Again, has to reconfigure the DHCPs. It has to reconfigure the console servers so that accessing consoles by machine names works right away. I developed our auto-install stuff on the VM platform, and the ability to immediately see what's going on is very important there. And it has to reconfigure the VNC proxies so customers have access to the VGA consoles. And all that has to happen very, very dynamically and automatically. Kind of challenging with another talk. Then we do the regular auto install, like I just described for the physical machines. And our install on site as last step signals completion by making a special HTTP request, which causes our system then to stop the VM, reconfigure the networking to put in the target VLAN and start it up again. And last but not least, of course, mail out the install report to the customer so that they actually know how to access it. It's IP address, the password, and stuff like that. So, a kind of expected use of OpenBSD in such an environment, of course, is firewalls. If you know what I keep working on in OpenBSD, you'll be very surprised that I actually use BF. I always, in our environment, we always deploy firewalls in pairs with failover config. There is no other option. The firewalls are a bit different than the usual case. Basically, all the textbook descriptions don't cut it for us. Our policies are on the VLAN interfaces and not on some external ones, because we need to isolate the customers. We'll be getting into more details in a little bit. And the router-facing interfaces, the external ones, really only do some spoof protection and protecting the firewalls themselves. Also kind of expected, we use OpenBSD for our routing needs. We are not pushing hundreds of gigabits, so we get away with commodity hardware-based routers. I also use OSPFT a little bit, but I could get away without it because our network in that corner is easy enough to do static routing. This is really just optimizing traffic going from one set of firewalls to networks behind another set. So that's routed directly without going through the core routers. If that goes down, there is not much fallout, basically nothing. The upstrings, that's basically VLANs over fire runs to 2 remote sites, also in Hamburg. It's these 2 remote sites, that's where we buy bandwidth and do all our peerings. On the remote sites, we only have networking gear. Obviously switches, and one of the remote sites is connected over SONET, so there's some SONET gear. The other, that's much nicer, is just a roughly 8 kilometers long dark fiber. So get long range optics, plug into your switches, run Ethernet, problem solved. Very convenient. And this link had only one short outage in more than 10 years. Layer 2 is challenging in these kind of networks because you have to deal with these many VLANs and very, very frequent changes. Like it's not very static. First, new customer, new VLAN, right? About new customer, the only hardware or dedicated hardware. We actually have to group the switches with separate VLAN namespaces. Once because they're only out for 1,000. We're not using that money actually. But most switches are limited to less, like 250 or 500. So we have to separate that. Our system uses the switches command line interfaces to configure them. We first doing that over SNMP. If I looked into it, forget it. Too much of a hassle. Our system basically has plugins for different vendors and product lines and abstracts all the differences, so we don't have to worry about that. And we still use SNMP, but read only for statistics and all that kind of stuff. And basically, when we are plugging a cable to a switch, we tell our system which machine is connected to that port, and from that point on, we only deal with the machine name and never with the switch port anymore. And our backend, of course, knows which VLANs the machine needs and can then set up the ports as needed. That unfortunately is not it yet. In this environment, you have to apply what most vendors call port security and MAC lockdown. So the ports are not learning MAC addresses, they are statically configured. And no others are ever learned or showing up. And if we see another, we get alerts. We also want to filter CARP announcements. CARP is much better than VRP in regard of replay safety. CARP actually has proper crypto, but these protocols, out of principle, the way they work, can never be 100% replay safe. So in most cases, I'm trying to avoid using the multicast mode, specify CARP here, so it's unicast. Doesn't work everywhere. So the switches have filters on all ports, but the ones for the CARP machines, to drop the CARP announcements, so third parties and customers cannot even see them. Also have to deal with LSCP and RSTP, of course, but I'm saving you from the details here. And it has to turn the ports on and off, because, of course, each and every port that is not being used is off. I'm a bit behind time. Mail platform is kind of interesting, because these days email is so incredibly complicated, and it is a lot of workload. So if you're running your own mail server, why are you doing it? It's so much work. I really don't recommend doing that anymore. The biggest problem, of course, is spam, and the problems that come with the amount of spam and the filtering requirements. For an ISP mail platform, you've got to have quite a few components. You need the MX front ends, you need the SMTP servers that your customers point their mail clients and own mail servers to. You need to supply POP3 and IMAP and webmail. Of course, you need storage, you need an authentication backend, you need the mail routing configuration, And you need a lot of anti-spam measures, and related to that, the policy systems, including DK and DMARC. So our mail platform is built around a fork of Qmail LDAP. Qmail LDAP itself is a fork of Qmail, which fortunately has been de-Bernsteined a little bit, so it's quite readable. I'm not promoting Qmail here. In 2000, the options were sendmail and Qmail. Postfix started to show up, and XIM is so wrong that it never was an option anyway. Qmail has been misunderstood. Qmail is not an MTA, it's a collection of building blocks to build your own. If I put, again, sense of pattern here, if I'd start this from scratch today, I'd probably take the SMTPD from OpenBSD base and extend it until it fits our needs. Changing that is close to impossible now. And there's no point, there's no need. Our own fork is kind of forced. I don't think it really is avoidable to make custom changes for a mail platform this scale. Like we really handle a lot, including some very, very well-known big entities for them. Of course, in our setup, this is all virtual users and not Unix system accounts. Once because it's way too many, and also because the requirements in regard of flexibility and dynamic creation and vanishing are, that just doesn't fit the model of Unix system accounts. So instead, user accounts are LDAP objects with quite a few properties. One of the most important ones, of course, being the path to the mail where the mail is being stored. These are automatically created upon reception of the first email, and we send a welcome email to force creation. It has mail addresses as properties. This is more than one, so just assign many. There is no concept of an alias because basically it's just a property of the user account. There can be forwarding addresses, yes, more than one, then you send multiple copies. Of course, things like the account status, is it disabled or is fetching mail blocked? There's configs for autoresponder and bits like that, and the per user anti-spam configuration bits. The domains we handle mail for, surprise, are LDAP objects again, and last but not least have the per domain anti-spam configs, including the settings and keys for DKM and DMARC. We use multiple LDAP servers there replicated, which works very nicely in that regard because all the mail systems only need read access. You only need write access to change config, and that's different systems, the backend systems. So the mail exchanges, the MXs. The local ones all just mount mail storage over NFS. Maildir is NFS safe, fortunately. And the remote ones basically relay to the local ones. It's a bit more complicated than that, but basically. We do run the OpenBSD spamming and gray listing mode on each mail server, not on the firewalls up front, on the mail servers themselves. Use the built-in replication, and we use the gray listing time to run a very customized gray scanner, loosely based on the one that Bob wrote a couple of years ago. But that is not running on the mail servers, that is running on different hosts yet again, for performance reasons actually. Because that is kind of slow because it has to do so many lookups. Most of the gray listing problems that people run into, the disadvantages, are simply solved because we have enough mail volume and the whitelist is very big and basically contains everything that we want to talk to all the time. So we do handle Gmail and the likes, we do retries from different IP addresses differently, but we don't even need to because they're always all whitelisted anyway. We get so much mail from them, problem solved. We do play some TF games there. limit the maximum number of connections, remote IP address can have to our mail service, do a little bit of connection rates limiting there, but that really is elsewhere. And we play a little game with applying stricter policies to mail coming from Windows hosts, because there is not all that much legit email coming from Windows mail service on the internet. There is, so you can't just drop it, but you can apply little stricter policies. The SMTP drops are even more complicated. We have multiple groups there. The regular ones that clients point their mail channels to. We have bulk mail instances for mass mail senders and relays for customers with their own mail service. All these are part, so to provide redundancy. The big problem in that, the customers who send out big newsletters, these should not delay regular mail. And telling customers to please use the bulk mail instances for their bulk mail needs, well, customers. It doesn't work. They point their system to the normal mail relays and deliver that mail with 100,000 or a million recipients. So what we do there, this is legit mail. We don't tolerate spams. What we do there, whenever they exceed a certain limit per session and per user, that's a rate limit, we don't enqueue that mail in a regular, and the number of recipients too, of course. We don't enqueue the mail in the regular instances, but we basically redirect it into the bulk mail instances and have them handle those mass mailings. The policy daemon, that's very custom. And that's code that we're not going to publish. All our mail server instances replace the enqueue program with a small client to our daemon that I wrote in C because it's forked all the time, so startup has to be fast. The basic concept is we either refuse the mail in the SMTP dialog or we deliver it. Just dropping it is a big legal problem for service providers. You are basically not allowed to do that. Many do this wrong and do it nonetheless, but it's a very fishy topic, a very delicate topic. The only way you as a service provider are ever allowed to drop an email is when the target user, not his company, the target user selected that option. So our web interfaces provide that. And that's the only case where we in some circumstances ever drop emails highly. The policy daemon itself is once again written in Perl and it incorporates all the spam assessment Perl modules, not the spam assessment front ends, but the Perl modules that spam assessment is using behind. One bit that's a bit complicated to deal with there is the per user and per domain Bayesian filters and the gazillion of training options. It does DKIM signing and verification. DKIM is basically, or DKIM as part of DMARC, is our best hope to get usable email again. But even that hope is not too big. It also inserts the authentication results headers that better email clients use to show the verification status to the user. And it also has to use SPF. SPF by itself is utterly useless because the guy who came up with it doesn't understand email. It breaks forwarding. It, however, is useful as input to DMARC. We are also interfacing Clumdy for the clients who believe in virus scanning. I don't, but customers can. It applies rate limits. It fetches the per domain and per user configs from LDAP. And it, for detected spam, customers want different handling for detected spam. And it also depends on whether all destination users have the same setting or not. This is becoming quite complicated if it has multiple recipients in our network, can have different settings. So they either just reject or drop or just mark it in the header or rewrite the entire mail to make it safe to display in private mail clients. Redirect it into a spam folder, which the daemon itself cannot do. It basically just marks this, and the delivery process later takes part of that. Then there's the, running out of time here, POP3, IMAP and webmail front end. POP3 is QMAP LDAP, POP3, IMAP is GovGuard, all using the LDAP authentication backend. Webmail is a very customized round-trip one, including some homegrown or modified plugins. Several of our customers say it's so good that they uninstalled their local mail clients. It's really, really nice actually. I like it, and it's a webmail thing. A surprisingly complex topic is the billing. You have to automate this. You cannot handle this manually. There's no way. A very surprising part is you have to delay the actual generation of the invoice document very, very far. The VAT or sales tax decision is surprisingly complex. Thank you, EU. Do we apply the German VAT, or is it the EU reverse charge mechanism, or do we have to apply the customer's country's VAT? Yes, we have to charge French VAT to some French customers, and to Greek customers and so on. You also need to know, are you selling goods or services? Because that makes a big difference. If it's a service, is it electronically delivered or in person? And if it's not electronically delivered, what is the legal service delivery location? Which is not as obvious as it should be. You also want to do automatic settlement of credit notes and credit for earlier overpayments, because otherwise that's manual work and that's expensive. You also have to decide upfront whether we are doing the SEPA direct debit thing, where we basically pull money from the customer accounts. The regulations for that are very complex, so we have to verify that the mandate is still valid and has been used in the last 12 months, or we cannot use it again. You have to follow the regulations on when to debit the customer account, and the pre-notification requirements are also quite complex, and that pre-notification has to show up in the invoice document, so you have to decide on all of that beforehand. Do we want to offer PayPal? We don't want to offer that when the amount is too high because of their excessive fees. Is the invoice in German or English? And is it going outside the EU? Because then we have to include way more information for them to be able to do a bank transfer. Is it going to be mailed out on paper? Yes, that still exists, unfortunately. If so, it might require a stamp. And for that, we need to interface with the German postal system, Deutsche Post. The bad part, that interface is SOAP. The worst part, I didn't find any existing implementation, except their own for Windows. And I even have to incorporate image magic because the stamp they return is a PNG image. Of course, this comes in a zip file to make it even more complicated. The zip file around a single PNG. And the PNG has excessive white space around it that we have to cut first. Awesome. Yeah, fun. So now finally, we can generate the PDF invoice. We are using PDF LaTeX and our template engine. QR and barcodes are generated on the fly. And well, invoices should be long-term archive capable, yes.
What do you use to generate the QR codes?
A Perl module. Forgot what it's called. So, long-term archive capable is a big deal. There's a standard for that, PDF/A, and the reason the PDF/A-3B variant. And to be able to generate those standards compliant, we even had to modify PDF LaTeX, only slightly, two-line-ish, but still.
What's the difference between a normal PDF and a PDF?
Oh, the archiving standard denies all forms of active content. Like, no, you can incorporate Flash and JavaScript and whatnot, so all that is forbidden. all fonts have to be embedded, all images have to be embedded.
Right.
It's basically cutting away all the features that make PDFs strange. The idea is open this in a PDF reader in 20 years and it works.
Right.
It looks like it does today. Our invoice PDFs also contain structured billing data that is basically an XML file. And well, that standard is called Zugpferd. It's, as the name kind of gives away, is being pushed by German authorities. Authorities writing standards always leads to brilliant standards, right? So this is German authorities pushing a standard onto EU standard bodies, and in turn this is based on standards by the United Nations. Well, all these standards we usually deal with suddenly look so simple and sane that it's don't get me started. So finally we can generate our PDF and put it into our document management system and of course email it to the customer. Not fully done yet. Bookkeeping is not just a task for the tax advisor here. With the amount of invoices being generated, many of them of course being kind of small, handing over paper to a tax advisor, sorry, that doesn't cut it. So the focus in that bookkeeping really is tracking payments, like tracking payment status and reminding customers when they forgot to pay and take it further if needed. So the focus is not the tax part. To get outgoing invoices, of course, are easy. This is completely automated. Incoming invoices, we have to book and put the PDF into our document management system. We can handle some completely automatically. However, a large part actually still comes in on dead trees, so that even needs to be scanned. All that, fortunately, is a trained monkey job, so student, cheap. I would prefer this to be fully automated too, of course. And last but not least, you have to export all that stuff to your tax advisor so he can do the complex parts that I don't understand to begin with. Finding one that can deal with that was kind of hard. The monthly tax pre-announcements, our system spits out itself. First, it's easier, more efficient than doing that through the tax advisor. That also, unfortunately, tracking payments means you have to interface banks and PayPal. PayPal is easy, banks are not. There finally, I've been looking for that for ages, there finally is a Unix command line thing that implements the required protocols called AQ banking. Of course, it had to be ported to OpenBSD first, and I did that. I had to fix a couple of bugs in it itself to actually work. But now it's quite nice and works. We're using the regular Perl modules for PayPal, and this I found amusing. They implement pretty much each and every API call that PayPal knows, except for get balance. There was no way to get the balance of your PayPal account, so they had to add that themselves. The tasks for the legal banks, we need to send these direct debit things and regular payments because we have to pay invoices too. In both cases, retrieve transactions and balances, and well, in the PayPal case, the usual painful PayPal checkout process. We want to have this largely automatic, right? So for transfers we generate, that's easy because, well, we control the text and can put in whatever we want. Incoming regular transfers, the purpose field is free text and customers put something in there. There is a partial solution for that in C++, but it's not common, so we kind of rely on it. So we try to find anything that looks like our document numbers in the text, retrieve the records, and if the amount is in the window, wait, window? Yes, because if a customer pays late, it might not be the invoice amount, but the invoice amount plus late pay interest. If it's in the window, book it automatically. If the system is not utterly sure that it's doing the right thing, do nothing and leave that to a human. It works so well that way more than 95% of all transactions can be handled without human intervention. Of course, for the host handling all that, I mean, it's interfacing banks. So money, security is very important. At the the same time, it has to be internet connected to be able to talk to the packets. Well, I really would not want to run this on Linux or even worse, Windows or even worse, Apple. Well, thank you OpenBSD for keeping my bank account safe. Using OpenBSD for all these core services has really paid out for us. As I keep mentioning, security is the foundation of all of this. We never ever had a compromised post, and it has mitigated third-party security issues. For us, it's extremely efficient in terms of human work hour consumption, and that is a very expensive resource. And again, the margins in this business aren't high. As mentioned, stability is good, awesome, never a problem anymore. Performance is at least good enough, don't have to worry. Very good fit for our use case. And that's it basically. Thank you for listening. I'm playing a bit advertising more today. Please pay attention to one of my new ventures. And questions? Yeah.
So regarding German privacy laws and regarding also other government introspection of your services or customer servers or et cetera, has that played into any of your design decisions as you've done this?
A lot.
What are the rules really? What are the rules that affect?
How much time do we have?
The high points, yeah.
Let me try to abstract this out. Yeah, data privacy is a big deal, which does not affect us that much for one simple reason. The standards I apply are even higher. Because, well, but yes, keeping customer data secure is a big issue.
But then how do you balance that then with the other, government introspection?
There is none.
None.
They basically only act when there's a breach and somebody complains, and we obviously never had this. Actually, this is kind of funny. I mean, German authorities are world known to be horrible to deal with, right? You're trying to get something off them and you feel like you're asking them a favor. It really is not like that anymore, and I keep being surprised about that myself. The tax authorities call me when they have a question, instead of sending a letter with a set date where you have to have replied. That's surprisingly nice.
But do you have cases also then on the other side of this, where do you have cases where the government comes to you and says, hey, we would like all the logs, secretly for such and such from such and such customer server, or hey, we would like some private keys for something, or hey,
The typical German way these days is create some laws that don't quite make sense, make it mandatory. Once it's mandatory, everybody knows that it's complete and utter bullshit. Like, for example, the data retention for email crap says you have to record the subject line, which MTAs usually don't even see. So everybody is just ignoring that bit of the requirement, and the government is basically ignoring the ignorance of that requirement. That's very typical for Germany these days. And all the other things basically is they specify the requirements but never verify that they are being met unless somebody complains. And we never had to supply records, fortunately. But the ones we have to keep, we do keep, and the ones where I find them questionable regarding privacy, we try to make them as useless as legally possible. And try to store as little as possible. Because what's not there, they can't request. And they can't force us to supply when it's not there. It's basically the take on it. More questions? Beer? Too early?
Yeah. Do you implement IPv6 on your network?
I'm proud about a couple of things, but two things about my network I'm proud of is it's free of Cisco gear and it's free of IPv6. I do realize we will not be able to hold this on forever, but for the time being, Sorry, I mean V6, I've said this often enough, it's so wrong in so many regards, but yeah, it's too late, it'll come one day. I actually had parts of my network IPv6 fight more than a decade ago, like 2005-ish or so, and then decided that's crap and removed it from our networks. But yes, as I said, we won't get away with that forever.
How do you back up?
Have I?
Back up.
What? Backup. Yeah, that is complicated. Basically, that again is homegrown because back then nothing existed. It's a central host that connects to all the backup hosts over SSH pipes, fetches the data using dump basically. It also can use tar for other OSs. Puts them on RAID systems. The RAID systems have multiple copies, and the next step is the tape library. It's a little tape robot, which is, funnily enough, I just screwed this up because I changed cartridges before I left to Japan, and I missed that there was still a tape in the drive, so now the robot has no place to put the tape and switch. My guys are fixing this as we speak. And there is yet another tape drive that is only used once a month, and that tape goes to the safe at a nearby bank.
Use
rsync.
now from scratch. Do you use cloud backups?
Use what?
If you start from scratch, would you use cloud backup?
Yeah, right. There is no cloud. There's only other people's computers. And I'm not putting customer data into third-party hands. That would be a legal problem, which is not even the big point for me. I just find it unacceptable. I'm sorry. Customers give us data and trust us, and they trust us and not other parties. We also just sync some things to remote sites. We also sync many things over many hosts, so redundancy, of course, is king. And yeah, we really play that. I mean, I'm playing redundancy to the level that I always travel with 2 phones and 2 laptops. Unfortunately, only 1 passport. So yeah, redundancy is king. Don't need cloud for that. Okay, I'm over time. Thank you. That is all.